Hello everyone, welcome back to my channel. In this video I will show you how to compile and install wien2k. And on the left hand side you find a list of all of the steps that are necessary for the compilation. It may seem a lot, but actually I will walk you through each step and everything is quite straightforward. So before we start, I would like to mention that our system is Ubuntu 19.10 and we use Intel Parallel Studio 2019. So basically we use the Intel compilers. Before everything, I would like to remind you that you have to source the Intel compilers, otherwise it cannot find the path of the Intel compilers. And then we need to install CSH, because in Ubuntu this is not installed by default, and this is necessary for the wien2k. There's nothing down here because I have installed it before, but if you haven't done it for Ubuntu, you have to do it. And then the second step is to go to the compressed file for the source code and then decompress it. So we just use here, and the source code is decompressed into this folder called wien2k, and we go into that folder. Then we need to use this script to decompress all of the subprograms, but before that we need to change the permission of that code, otherwise you cannot run it directly. And then we run the code, and then yes. Okay, so wien2k is now expanded and we need to configure using this script here. Okay, and you see that we must change our locale because in my system 0.15 outputs 0,15, and if this is the case for you, you need to export LC numeric to be enus, and we just go to .bashrc. which we put to the end, and then we need to activate the .bashrc. Okay, I found on my system that this line does not really work, so I added UTF-8 to solve the problem, but probably you have some other options to do it. Okay, and now we need to run the configuration again, then return to continue, and it's LI, so it is Intel compiler plus MKL plus Intel MPI. So this is what we want to use, and then return. For the compiler, actually in my case, ifort give a problem, so I would use MPI ifort here. And then the C compiler, we use ICC, that is the Intel C compiler, and then return to continue. Okay, continue. And no, there's no libxc. We need to change the compiler options here. So we select O, and then we use the option that we wrote here. Basically most of the things are similar as the default, except that I took away this VML flag, which gave some error, and I add -03, that is a high-level optimization to make it faster, and this is the architecture-specific flag. According to my CPU, that is i7 8th generation, which is Skylake architecture, and we need to use this architecture-specific flag to optimize it. If you don't know which flag to use for your Intel CPU, you can go to the Intel compiler options for different architectures and then scroll down to the bottom. You will find, for example, in my case, 8th generation Intel Core processors, that's Skylake. If you have Xeon processor or some other generation of Intel Core processors, the corresponding architecture is listed here. And then if you scroll up, just remember Skylake, and it is here. We need to use Core AVX2 flag. And for this website, you can either search in Google, or I also wrote out the web address here. So take a look what is the architecture and then choose the optimization flag for your architecture, and I think that's it. We just copy it here, and you see that it is updated. For the rlibs, we also have to change it. And this is the linker for the MKL library, and for that you can search online to this MKL link line advisor. Choose the Intel product. For us it's Parallel Studio 2019, and Linux compiler is Intel Fortran, and architecture is Intel 64. And for this you can try static or dynamic. I would use dynamic. And the interface is 32-bit integer, and the threading layer I would choose sequential. Of course you can try OpenMP or TBB threading, but to keep it simple I just choose sequential. And then for the cluster library we use scalarpack blacks and also BLAS95, LPAC95, and then we choose Intel MPI. I will link with the MKL libraries explicitly. Yeah. And just to make it safer, we also choose CDFT, but maybe this is not necessary. Okay. And then we basically use this link line here, copy, and use the same thing here, yeah? Except that there's one difference, that we need to change the style of the bracket from this to this one, yeah? Otherwise it will give some problem. So here, we just copy and paste here. Yeah, and you see that this is updated. Okay, and then we save and quit, continue, and now is the configuration of the parallel execution. So yes, it's shared memory architecture because we only have one computer, and then no, there's no specific command. And do you have MPI? Yes. Compiler MPI import is default, so we just hit enter. And then we have a scalarpack installation, that is the Intel MKL. It is already successfully detected, so yes. And then Intel MPI, yes. Do you want to use the present FFTW installation? No, because we didn't compile the FFT3 library manually. In principle, for higher efficiency, you need to download FFT3 library and then compile it with the Intel compiler and then link it to here. But here we just say no, so we use the intrinsic one. And we also don't use the ELPA. So we don't change the MPI run command, just enter as default and enter as default, return to continue, accept, continue. And because here it is recommended that for 4 GB of memory we use mmat_max to be 20,000, and it is square root behavior, and in my case I have a memory of 32 GB, so we use around 55,000 for mmat_max. So we change it, and mmat_max to be 55,000. Continue. And then actually it is said that NUME equals mmat_max divided by 10. So this is fine. And quit here. Okay. So in principle you can start now the compilation of all of the programs. However, I would suggest that you try the compilation of a small program first, because there is a strange design of the compilation of wien2k that if you compile everything, it will ignore all of the error messages and just continue to the end. So if you decide to compile everything, it's better that you closely monitor the process and see whether there's any error. But here I would really recommend that you compile a subprogram of wien2k first and see whether there's any error. However, this is not really designed to be done, so you have to quit by pressing Q. And then we run the configuration again. So here you see that there is an option of compile and recompile, and then we have the new option to select a program to compile, and in this case we just put in LAPW0, and this is one of the subprograms in wien2k. Okay, so you see that there is no error message, seems that everything is okay. So we return to continue. So now we make sure that the compilation works for one of the subprograms, so most probably it will work for all of the programs. So now let's just compile all programs, and this will take a while, and we just wait. Now everything is finished, we have compiled all of the programs, and you see that there is no error here, so the compilation is successful. We return, continue, and quit. Before we run the program, we have to configure the environment using this line here. and I change it to gdit here. We use the default data directory and default scratch directory. PDF reader, we set it as default, although I don't have acro read, doesn't matter. And then yes, continue. So basically it will add the environmental variables to the .bashrc file, and here no. Okay, so the environmental variables are written in the .bashrc file, and then we need to restart the shell or source .bashrc to make it into effect. Okay, and you see that there's a error message here that we cannot modify the stack size limit. Let's take a look in the .bashrc file. And basically those lines are added by wien2k, and the problematic line is here, ulimit -s unlimited. It tries to set the stack size to be unlimited. However, in Ubuntu I noticed that this will usually give an error because there is a hard limit for the stack size defined by the system configuration file, and you cannot increase the stack size limit above this hard limit. Comment it out, and then we change it to what we had before. So we change the stack size limit to be 256 megabytes, which should be enough for most of the cases. Okay, so that's it. Now the configuration and installation is done. We can try to run the W2 web, that is the user interface for wien2k. W2 web, and this is the first time that I run this, so it will create some folders and files, and we need to set a username and password. So we just say admin, and the password is also admin, and the port we just use 7890. In principle you can choose whatever port number you want, just you have to remember that. Okay, this is the master node. Yes. Okay, now everything's done. Go to the web browser and navigate to this address here, and you need to type in the username and password, and OK. So in this video I have shown you how to compile the parallel version of wien2k using Intel compiler on Ubuntu. And in the next video I will show you one simple calculation. If you learned something from my video, I really appreciate your like or subscribe to my channel, and I hope to see you next time.